Hi, I'm Kogulan Ganesh from RY32. My metric number is 211363352 and the subject is Control System Technology, Lab 3, Root Locus. And the instructor name is IR Dr. Muhammad Zamri bin Hassan. For Lab 3, Root Locus, we know about the root locus, which is an open loop transfer function. GS is the locus plot of all possible location of the closed loop poles with unitive feedback and proportional gain k that is varied from 0 to infinity. So these are the diagram, which is the closed loop system with k gain and unity feedback. The first one is step, the second one is sum, and the third one is gain, which is k, and the transfer function is gs, and finally scope. So for the exercise 3.1.1, the question is 1 over 3s square root plus 5s plus 1. And for 3.1.2 is 5 over s cube plus 3s square plus 5s plus 1. And for the exercise 3, s square plus 6s plus 1 over s cube plus 3s square plus 5s plus 1. So these are the first three exercise. For these are the coding for the exercise, which is the numerator is 1 and the denominator is 351. For the GTF, we need to add the numerator and denominator, and these are the roots for the numerator and the roots for the denominator. After that, we need to do the R locus, which is for the numerator and denominator. So these are the numerator and denominator. And then here we go. These are the answer, which is we got 2 poles and 0 zeros, which is 1.4343 are here negative, and here are the negative 0.2324. Okay. For the exercise 2, the numerator is 5 and the denominator is 1351, which is s cube plus 3s square root plus 5s plus 1. So these are the GTF, which is the denominator and the numerator, and these are the roots for numerator and denominator, and R locus. By doing this, we get this answer. So the first one is the imaginary, for the first one is the blue one, and the second one is the red one, and for the final one is the green one. Okay. And for the third exercise, the numerator is s square plus 6s plus 1, and for the denominator is s cube plus 3s square plus 5s plus 1. So these are the GTF, which is the for numerator and denominator, and these are the two roots for numerator and denominator, and finally we do the R locus for both numerator and denominator. For we get two type of answer, which is this answer is showing the blue one, and this answer is showing the green one. Okay. And then we go for the exercise 3.2.1, which is these are the coding for these are the output for the coding, which is for the 3.2.1, and these are the root locus, which is the x pole is for the poles is negative 1.4275, which is here, and the negative 0.2391, which is here. So after we get the two poles, we need to find out the k, which is the k is 0.0130. After then, we need to choose the selected point. So the selected point is this 1.4307 and negative 0.2360 for root locus. And for the exercise 3.2.2, these are the output, which is negative 0.8301 minus negative 0.025i, and for the k, which is 1.0833. for the pole is 0.8354, and another reading is negative 0.8312. So these are the two poles, which is negative 0.8301, which is here, and negative 0.0025, which is here. For exercise 3.2.3, these are the output, and these are the root locus, which is the selected point is negative 1.3164, which is here, and the k pole is 0.5148, which is here. And these are the poles, which is 1.3164, and here is the negative 0.0085 and negative 0.0085, which is these two, and these are the imaginary pole. For the next one is the exercise 3.2.4, which is these are the output, which is the selected point is negative 1.9787, and the k is 2.1243, and these are the poles. For these three poles are these three one, and then for the k is here, which is 2.1243. So these are the root locus. And finally, for the discussion, as a graphical apparatus, For control framework examination and plan, the root locus strategy offers imperative bits of knowledge into how distinctive controller changes influence the execution and steadiness of a framework, utilizing the system characteristic condition as a basic system. Root locus examination plot the root of the closed loop exchange work versus a variable pickup parameter. As a rule, a proportional gain k. This method is a basic of figuring out the system behavior at the different pickup setting. The most objective is to assess how the framework responds to the varieties in gain. The root locus strategy is utilized within the plan of controller such as PID controller, which is we use there. To ensure the required flow and steadiness of the framework, a point-by-point solidness consider can be performed by looking at the direction of shaft on the complex plane, which is S-plane, to decide whether the framework remains steady became the unstable or make strikes as the pickup changes. To put in essential, the root locus strategy may be valuable instructive in understanding and adjusting control framework. Its significance stems from the capacity to clarify how changes in controller pickup setting influence execution and steadiness. As such, it turns out the essential for the control framework innovation lab and classroom alike advertising signification and experience for both common sense and guidelines purpose. For the conclusion, root locus investigation offer imperative experience into the soundness and temporal responsiveness of a control framework. Through the investigation is a closed loop post-development in reaction to parameter changes. We are ready to assess the system execution and make well-informed proposal with respect to controller plan. The parameter values that result in either steady or unsteady closed loop framework are graphical spoken to by the root locus plot. Besides, they empower us to select the right pickup and improve the framework execution. To improve the execution, this down to the Earth lab work out has made strike our standing of the root locus approach and move forward our capacity to create a access control framework for genuine application. For this lab, that's all. Thank you.